Hey everybody, this is Chris with Overclockers Club. We've got something cool here from Corsair. Okay, so it is always exciting to see something new from Corsair. Let's see, so it looks like everything's right here on the back of the box, so let me zoom in on that. Okay, so the details on the side panel, let's see, the first one here, dimensions, we've got 153 by 155 by 164.8. The height is the one that's usually the most important, and we'll show that when we do an installation, why that's important. The weight is 1.5 kilograms or 1,550 grams. Heat pipe configuration, we've got 6 heat pipes, 6mm diameter, sintered copper, that's pretty common. Base plate configuration is soldered, convex copper base plate. We'll look at that a little later also. Fan bearing is FDB, which stands for fluid dynamic bearing. Fan is a 140 by 140 by 25 millimeter with a fan speed minimum of 400 RPMs. Max is, 1,600 RPMs. Airflow, we go up to 84.5 CFMs, which is pretty good, but that's, for a 140 millimeter fan, that's right in there. Pressure, we go up to 1.73 millimeters of water. Fan noise, looks like it tops out at 33.9 decibels. And this is the side panel on the back of the box. It shows, again, the 6.6mm heat pipes for high efficiency heat transfer. The fans that are used here are the AF140 ELITE PWM fans with air guide technology. The air guide technology is just a way to help direct and focus the airflow. Slim slide and lock fan mount system. That is also pretty cool. We'll see that in detail in a little bit. Pre-applied XTM70 thermal paste for easy installation and excellent heat transfer. Compatible with all your latest sockets, LGA 1700, 1200, 1150, whatever. There you've got for Intel, and then on AMD you've got AM5 and AM4. All right, so let's get it out of the box. There we go. All right, safety and compliance, warranty guide. Okay, looks like there are 2 fans. And let's see if that's it. Yeah, it looks like that's all there is in the box. So this is the cooler, the fin stack. Oh, okay. So it looks like one of these is a fan and the other one is probably mounting hardware. All right. Oh, it's nice the way that box opens up for easy access. And let's see. Well, that's a nice looking cooler. Has a matte black finish. It's pretty heavy. And you can see on the bottom here, and I'm going to leave this protective plastic cover on, it has the thermal paste pre-applied. So you can see it there. And again, I'll keep that on there till we're ready to do the actual installation. Looks like there's a little cardboard protector to keep everything from rubbing together during shipment. And this is installation hardware. We'll look at that here in a moment. And then fan number 2. That is a nice looking fan. Has a pretty robust chassis. And of course it is a 4-pin PWM fan. Okay, so looking at this cooler a little more closely, we've got the cool method here of the fan retention. It allows your fans to basically slide up and down a little bit if you need to make an adjustment. And where that comes in handy is on the end here when it overhangs your memory. You need to be able to clear your memory if you have tall memory in particular. And this allows a really quick and easy way to adjust your fans to the right position. And let's see, we'll go ahead and get the second fan on there. And you can actually add a third fan here. There's actually brackets here on either side, so you can put a third fan on there if you want. Now, all the testing I've done over the years with 1 and 2 fans, there is a benefit with 2, but it's not twice what you would see with a single fan. It's actually a little less than that. You might think intuitively if 1 fan is good at a certain rate, the second fan would double it, but it doesn't quite work that way. Okay, so we've got this is our splitter. So this is what would plug into your motherboard, and then the 2 fans would plug in at those ends. Okay, so we got some fan clips, AMD retention, thumb nuts. Let's see, we'll have to see what those are. And Intel retention. It's interesting, the white bags, usually they're clear plastic Ziploc bags, so these are kind of crinkly. Let's go ahead and open this up. And more white bags. Okay. All right, there's not an easy way to open that without destroying it, so I guess we will destroy it. But that's okay. All right, so there's 1 fan clip. Number 2. Okay, I see. So we need these screws to attach the clips to the fans. All right, so let's see. Yeah, we can use this one as an example. You can see how they're attached. So, and you may have noticed when I opened the box initially, there was no instruction manual. There was just safety and compliance and a warranty guide. That's because you have to scan a little QR code here on the box flap. That's how they do it now. So scan that, and that's how you get your quick start guide. Okay, so before we attach those, let's pull the current fan out. This sort of comes out. There are little detents there that sort of hold it in position, but you can see there's a little L and an R, so you get the bracket on there properly. And the way this is positioned, the airflow is going that way. So if we put the next fan in the same orientation, that helps ensure that we get the brackets on there properly. So the left hand bracket, again, there's the L, goes on there like that, and the right hand will go on like that. So let's go ahead and get these connected or attached using my handy Corsair screwdriver, if you can see that. All right, almost done. Get these snugged up. All right, so now this one is ready to attach. One thing I do want to talk about here real quick before we put the fans on. Of course, we've got the 6 millimeter diameter heat pipes, and we've got 90 nickel plated fins, and the edges there are serrated to help break up the turbulence of the air, and it's basically to help reduce noise. And again, we've got mounting brackets in positions so that we can put a fan, we can actually put 3 fans on here if we want. Now, a lot of people think that these heat pipes are solid. They think they're solid copper, and they're actually not. If you cut one open, like I did here, you can see, and this is an old, very old heat sink off of an old Dell server. But if you look inside there, you can see the tubes are not solid, they're actually hollow. And there's a very porous, sintered copper surface in there. And what it does, inside of these tubes, after they seal them up, you can see where they solder them shut. There's a little bit of water, a very small amount of water in these tubes, and it's the water that's actually transferring the heat. And basically, the liquid water down here accumulates on the base, and when it heats up, since there's a slight vacuum here, the boiling point is lowered, And the heat from your CPU causes the water to change to steam, and when it does, it absorbs a lot of heat, changes to steam. It travels down the heat pipe to an area of lower heat concentration, and then it gives up its heat as it travels along the fins. And then as it cools, it condenses back into a liquid. It soaks back into this porous inner surface and eventually wicks its way back down to repeat the cycle. So you just have this constant loop of liquid going to a gas, condensing back to a liquid. So that's how these work. So that was your crash course in how heat pipes work. So looking at the fans, if there's ever any confusion as to the direction of airflow and spin of the blades, they all have some arrows there. So this arrow shows the direction of airflow when the fans spin in that direction right there. So just helps when you're putting the fans on your cooler so you get the right direction of airflow. And I'll put the fans on after I get this installed. Now the system we're going to test it on is over here, and you can see it is a Z790 motherboard with a 13900K CPU. So we should be able to dump plenty of heat into this cooler. Now the TDP, or the thermal design power, is 250 watts, and the 13900K over here is rated at a little over 250 watts stock. That is the max. However, you can easily crank that up above that with an overclock and get a lot more wattage and a lot more heat to dump into your cooler. So we will test this under a few different conditions just to see how it performs. And now we'll drill down through the Intel hardware a little more. So this is your back plate. I guess we'll just go ahead and tear all of these open. So there's the back plate. Looks like we've got standoffs. And then, okay, we've got the clips. Kind of stuck in there. Got the clips. These are, okay, so they're for 1150, 152, whatever those sockets are, which we don't have, so we won't use that. And of course, we don't have an AMD board, so we will put those off to the side. Finally, we've got, let's see, thumb nut screws. Oh, okay, yeah. Those are what hold these down, but we'll see all that here in a moment. Now you can see on the base plate here, the ends actually snap into two different positions, and for this LGA 1700, these all pop to the outer position. And after you get the bracket lined up with the holes, then you use these little standoffs. Now you'll notice here the standoffs have a little isolator, insulator, a little plastic, or sometimes these are almost rubber, but that is what goes toward the motherboard. You'll see the other side does not have anything, so this is the end that you want to put facing the motherboard when you screw these down, and you just snug them up. You don't need to go crazy on the tightening. And then after we get all of these installed, it's a little hard to see with the memory in the way. But after all four of those are installed, you have to put these little cross brackets on right here, and you need to think about which orientation your cooler is going. So since we're going to have the airflow going across this way, I need to put these on there like that. And then we use the four little thumb screws here. These are what you use to lock your little cross brackets down. And again, you don't want to get too crazy on the tightening. You can just snug them up real well. And then we will be ready for the cooler. Now I always wipe down the top of the CPU there. Make sure it's clean from the previous install. There's always tons of thermal paste on there that I have to clean off. Okay, next is the cooler, and we will go ahead and remove a little plastic protection now. And then we can set this down. Let's see, we'll go this way. And it looks like I'm going to have to move my little auxiliary fans here. They are in the way. But we'll get the cooler down first, and then I'll get these fans removed. And the reason I added these was because when I do a lot of bench testing, you know, in a case you've got airflow coming through the case, but when you're out in the open like this, you don't really have any supplemental airflow. So they're getting in the way, so we'll just remove them for now. And just remember, when you tighten these down, the springs that you see right here, that's what's actually putting the force holding the cooler against the top of your CPU. So all you have to do with these screws is just snug them down. You just turn them until they stop, and that's it. And it's always best to alternate from one to the other. Do a few turns and then go back and forth until they're both bottomed out. And you'll know it when they hit the bottom of the travel, because they just won't turn anymore. Okay, so we can get the fans on now. And I want to blow, since the back of the case would be over here, this is where your exhaust fan would be. I want the airflow to go that direction. So we'll put the first fan on here, and it just slides over. And you can see down here what's important. Let me get a better camera shot of that. Actually, let me just take it off the tripod altogether. What's important there is the clearance. So depending upon what memory you're using, you need to watch the clearance. Now, when you move the fan up, that's fine, but you can see this offset here to clear the memory. Problem you run into, one is the higher your fan is, of course, you've got some air that's missing the cooler altogether there. But depending upon where your case, the side cover of your case is, you may get into that. So the overall height of the cooler is one thing, but the height of the fan after it's shifted a little bit, you also have to watch for that. So with that in mind, let's just consider the worst case. Let's just say that if I use this memory, which is fairly tall, I'm going to run into the situation where my case is shallow enough that this fan is going to hit. So what can I do? Well, I can easily switch these brackets to the other side of the fan, move this fan to the middle, and then move my second fan to this side. So the two fans, instead of being here and here, will be here and here, but that requires me to take the fan off and just swap these brackets from this side to this side. So I think that's what I'm going to do. And I'm going to speed that up a little and use my little electric screwdriver, but I only use this really when I'm taking screws out. I don't really want to tighten screws with this because the torque is not real, it's not controlled real well, and it has plenty of torque, and that's the problem, because if you're not watching, you'll drive the screw in, and if you don't stop in time, you will twist the threads right out of these plastic inserts here. So it's better to just use this to remove screws rather than put them in. So let's get these out and transferred to the other side. So what we want to do is basically move these to the other side of the fan. So that should, see if we install it like that, that should do it and give us the airflow direction that we want. See, I almost picked that up to put the screws in. I don't want to do that. Oh, actually, wait a minute. Is that right? Yeah, that's right. Threw me off for a moment. It's got some little side guides here that go against the edge of the fan to help keep them lined up. So I'll get these swapped over, and then we'll get the fans on the cooler and get the thing powered up. All right, we'll get this fan off, get the brackets swapped. There we go. And the reason I know that you can strip the threads out is because I did it a long time ago and learned my lesson on that one. All right, so let's get these flipped over. You'll notice these are not RGB fans. It doesn't have the extra RGB connector. So we're going to be kind of in stealth mode here with this cooler. RGB seems to have peaked for a while there. Everything was coming with RGB, and I like RGB. There's nothing wrong with it. But you get to a point where it's like, what else can they possibly put RGB on? There's nothing left. And that's okay too. All right, so we'll get these snugged down. It'll be interesting to see how this cooler performs, because so far, when I crank up the overclock on the 13900K, it pretty much brings every cooler I've tested on it so far to its knees for the most part. It hits the 99, 100 degree C mark, and then that's it. Okay, so we've got the brackets on there, so let's go ahead and get these fans installed. And that should be pretty easy. So we'll put one on here like, let's see, like this. And this one we can go all the way down, or very close to all the way down. And the second one will go on the back. Get it lined up. Let me get a little better angle there. Here we go. There we go. Now we're kind of hitting the VRM on the back side here, so we have sort of the same type of situation. We're either going to hit the memory, on the front, or the VRM on the back. Either way, we're going to have a fan sticking up, which the test case I'm going to use is the Corsair 5000X, so that should not be a problem. It's a pretty deep case. So we'll just leave it like this for now, and I'll go ahead and get the connectors plugged in here. Now on this motherboard, I've got dedicated connectors for each fan. I don't need to use the splitter. I can if I want to, but I don't need to use the splitter. Since we don't have a pump, we'll plug one into the CPU fan, and then the second one we will plug into the pump fan 1. And then anytime you power your system up with new fans or new fan configurations, it's a good idea to do a fan tune, so you can optimize the fan curve and the fan performance. So I think we are pretty much ready to power it up. Okay, everything powered up nicely, no problems. And this is what I mean by the fan tune. I always like to do that each time I do any sort of changes to the fan configurations or swapping out coolers. So it takes a couple of minutes, but it basically spins the fan from the minimum to the maximum and then develops the fan curve. One thing that I noticed that I like is since this fan here sits a little lower, since it is a 140 millimeter fan, you can see there's a bit of that fan down at the bottom. It's a little hard to see. A little bit of that fan overhangs below. You can see the blade spinning there. And what I like about that is it moves air underneath the cooler, helps circulate. If I can get this thing to focus, there we go. Helps circulate air around the bottom here where your heat pipes are, and it helps push a little bit of air down here along where your VRM is. So it's always good to have some airflow down around those motherboard components. So that's sort of a little added bonus. Okay, we've got the Prime 95 torture test running at a little bit over 5 gigahertz. Fans are maxed out a little over 1600 RPMs. We're hitting 95, 96 degrees Celsius. Your thermal, your TDP there, your thermal design power for this cooler is 250 watts, and we are at 287. This is hardware info that I'm using to monitor this. So we are pushing the upper limits beyond where this cooler is supposed to operate, and it looks like it's handling it. Now at the other end of the spectrum here, I bring the clock speed down to about 21, or actually 2.1 gigahertz, right around there, a little over 2 gigahertz. And our power now drops down to about 125 watts, and we're holding around 56, 57, 58 degrees Celsius, right around in that range. Of course, fan speed is, you almost can't even hear the fans now when they come down to that speed, but we're probably going to bump this up a notch and see where we are. And we'll let this go through the thermal soak for a little bit, let things settle. Okay, I went in and tweaked the settings a little bit. I dropped the voltage down to about 1.2. My target that I was trying to hit for the wattage was around 250, and I'm at 254. And now I'm holding it around 88, 89 degrees Celsius. And my clock speed, I'm right around 4.8 gigahertz. So that seems to be a sweet spot if we, sort of customize the settings to hit our target TDP without going over it, just to sort of show what a setup would look like for that. And this particular motherboard and this particular processor, this seems to work. And every motherboard, every processor is going to behave a little differently. The airflow through your system is going to have a big effect on it. So if I had this cooler in a case, and I'll show that later, you'll see that the temperatures can be a little harder to control because your airflow characteristics through a case will be different than they are when it's just sitting out here in the open. And here's the Corsair 5000X RGB case. You can see how large the cooler is inside this case. And this is a decent sized case. This is not a small case by any means. But you can see how much space it takes up. So that's why I always say those cables here in the back. Now this case isn't too bad. We've got quite a bit of room here, especially if this fan is not there. But sometimes it can be a real pain to get those cables plugged in as you're doing a system build. So you want to do that before you get your large CPU air cooler in there. So a couple things to point out here. If we look here, we've got clearance. We've got a notch cut in the bottom section of the fin stack here, and that is to allow for your RAM modules, your high or tall RAM modules. Now these are fairly tall because they've got the RGB effects going on. But if we go inside for a little closer look, you can see there is a several millimeter, probably 6 to 7 millimeter gap between the bottom of the fin stack here and the top of the RAM module. And you'll notice that back RAM module there is not populated. I've only got 2 of the 4 slots populated. So there is room for a 4th module and plenty of clearance. Now if I had the fan configuration different, if I took this fan and put it here, or I just had a 3rd fan, you can see how that adjustability for fan position is important for the RAM modules on this side. But what you have to also consider is these are 140 millimeter fans, so you don't have as much flexibility for adjustment as you would with 120 millimeter fans. So a shallow case might be a problem because you've only got so much room, especially if you have to kick your fan out a little bit like I do here, because bottom of the fan is hitting the VRM heatsink or the heatsink for the I/O back there. It's kind of bottomed out, so there has to be a little bit of an overlap here where the fan sticks out. And where that comes into play is when you put your side panel on there. This is smoked glass here, and it's a little hard to see what's going on. Let's see if I can shine my flashlight there. Okay, so you can see there's clearance there. I was able to get the glass panel on, but you can see if your case is shallow, then that's definitely consideration, because you may not be able to get the side panel closed. Okay, so I did the fan tuning, went through that little process real quick after I got the cooler installed and fired up. What I'll do now is stress this with the Prime 95, and I'll also stress the GPU so that we can see what happens there, and we'll look at the numbers. Now, this is a different processor on this motherboard. There, I got the panel off so we can see what's going on. But this is a Z690 DDR4 motherboard from MSI. It's a carbon Wi-Fi. And the CPU on this one is a 12600K. So it's a little different than the 13900K that we looked at earlier. So we shouldn't have any problems at all on this motherboard as far as controlling the heat when we crank it up. But as I mentioned earlier, one of the problems that you can have is if your GPU is pumping out a lot of heat, that heat is going to be exhausted. In this particular case, with this GPU, you can have exhaust air, hot exhaust air, sucked right into the intake here of your cooler, and that can affect your cooler performance. Okay, so what I want to show here is this is more like a real-world situation. The cooler is in a case. You've got a graphics card in there right next to the cooler. There's so many variables here that can affect your actual CPU temperature compared to when it's being benchmarked out in the open. Things like the number of fans, the ambient air temperature, how well the air flows through the case, what kind of CPU you're trying to cool, how much of an overclock you apply, what kind of graphics card you're using. All those variables come together and they will have an effect. So right now at idle, our overclock is around 4.6, 4.5 gigahertz. Idle right now is around 27 degrees Celsius, 28, somewhere around there. And this is with no load on anything. So first thing I'll do is leave the CPU alone. We'll just not load it up. And we will fire up the MSI combustor so that we can stress the GPU but not the CPU, and we'll see what that does to the temperature. So you can see the load on our CPU is pretty much nothing. It's idle. But we're already up to 35, 37 degrees Celsius because that warm air coming off the graphics card is being sucked into the cooler. And again, depending upon what type of graphics card you use, this can vary. And we may see as high as 40 degrees Celsius after we let this sit for a while. Maybe not. And if we look at our fan speed, our fan, let's see, the CPU's, it's really not spinning that fast. Doesn't have to because we're really not that warm. Now, what we'll do here is I will go ahead and only stress test. Let me kill the combustor here. So now I will only run the stress test on the CPU while the graphics card cools down. So right now it should be coming down, yeah, 40 C, and it'll keep coming down a little bit till we get close to ambient. But let me stress only the CPU. And again, this is a 12600 processor. So we'll let this run, and you can see we've punched it up a fair amount there with this overclock. Still well below any danger zone. Fan speed kicks up to around 1437, 1468. Looks like it's going up a little bit as the temperature increases. Now, let's go ahead and stress the GPU at the same time and see what that additional warm air does coming in. And actually it's not as bad as I was expecting. It's holding at a pretty decent temperature, even with the graphics card being stressed. So I was actually expecting this number to be a bit higher. I'm not complaining, that's certainly good. But we'll let it run for a little while here and see if it changes. So it hasn't really gone up a whole lot. That just tells me that there's probably pretty good airflow moving through the case. Otherwise we would see this creep up even higher. Now on a warm day, or if you're in a warm environment, of course your numbers will vary based on the ambient temperature. And just for the heck of it, I did bump the overclock up a little bit, and you can see our temperature kicks up a little bit. And like I said, all of these things can vary with how aggressive of an overclock you have. And let's talk price real quick. When this is released, it will be starting at $99.99 US dollars. And if you're in Canada, that's $134.99. And I think that's right in line for a large monster cooler like this. Well, I have to say I'm reasonably impressed here with the A115 here from Corsair. It's one of the few coolers that I've tested that could pretty much go toe-to-toe with the 13900K without going crazy on the overclock. You know, you can go beyond the limits of what this cooler can handle if you really push it. But for the most part, I think this would be fine for most people in most situations. Now, it is a large cooler, so you need to take that into consideration. It may not fit in everybody's system, everybody's case, because those 140 millimeter fans are fairly large, and if you bump them up beyond the height of the cooler to make things fit in your system, you got to look at how shallow your case is. But ease of installation, typical Corsair quality. We don't have any RGB stuff going on, but it doesn't need it. It has a really cool, stealthy look to it. You saw it there in the 5000X case. It looks pretty good in there. But overall, like I said, I'm pretty impressed. So I would give this the Overclockers Club Editor's Choice Award. So this is Chris with Overclockers Club. Thanks for watching, and don't forget to subscribe.